Hello, my name is David Strauss, and as a founding member of SciCord, I want to welcome you to a structured work process demonstration using SciCord ELN. A primary goal of SciCord ELN is to support efficient and compliant scientific documentation. Structured ELN templates are an important mechanism to increase both efficiency and compliance. In this video, we will demonstrate a controlled work process suitable for quality control or high-throughput labs. To get started, a new document is created based on a CBD template, which was designed to record the analytical work associated with compressed bulk density. The compressed bulk density analysis demonstrates a set of generic laboratory functions which will hopefully be relevant across many disciplines. SciCord ELN templates may be configured to fit a wide variety of analytical procedures and laboratory processes. This template lays out the sequence of operations in 3 notebook pages or worksheets. The first page, labeled Samples, is designed to define the work to be done, the samples to be tested, and display the final results. A second page is focused on the equipment and materials required for the analysis. The third page, labeled Test, supports documentation of the test procedure. This template implements a color scheme to simplify and streamline the documentation process. Gold indicates cells where data or observation entries are expected. Gray cells contain locked calculations or system-generated information. A purpose is recorded in the cell provided. Next, samples are associated with this document. A sample dialog is displayed to identify the samples to be tested. Samples are selected in the dialog and added to the queue. In this case, the sample dialog is defaulted to display relevant QC samples, but the filters can be adjusted to find alternate samples which may require analysis. A sample table displays the associated samples, including sample attributes and analytical method. Note that the columns for final results are included in the sample table, but are not yet populated. The number of test replicates is selected for each sample from the drop list. This completes the definition process, and the resources page is next selected. The equipment and materials required for CBD analysis are predefined on the resources page. Buttons on the page allow additional resources to be added if necessary. A resource tool is provided to record the analytical equipment. The tool automatically excludes equipment which is not in service or equipment for which the calibration date has expired. Resource categories allow drill down to specific resource types. The available balances defined in SciCord ELN are displayed when the balance category is selected. A link to the selected balance is recorded to the analytical document. In addition to the balance link, the calibration due date is also recorded to assist review and compliance audits. Equipment can be discovered using the quick search function. In this case, the environmental chamber is selected and recorded. The GeoPick instrument for measuring compressed bulk density is also searched, selected, and recorded to complete documentation of CBD equipment to be used in this procedure. Materials such as standards, chemicals, and solutions are also defined as resources within SciCord ELN. For this analytical process, silica gel is the reference standard and methanol is the diluent. Similar to equipment, materials can also be searched and recorded. Additionally, materials can have barcoded labels with unique IDs. The material ID can be scanned or manually entered to definitively identify a material. The silica gel barcode was scanned and automatically recorded to link the reference standard to the analytical document. In addition to recording the expiration date, the density reference value is also recorded. Reference standard attributes such as purity or density are now available for calculations in ELN template formulas or available for transmittal to instruments. This process avoids transcription errors and decreases review effort. Similarly, the methanol barcode is scanned and recorded. If inventory of materials is desired, a resource tab supports inventory transactions. A usage inventory transaction can be recorded to decrement the amount of material used in a document. The inventory manager tracks transactions and can report materials below a threshold which may need to be ordered. Additional information on management of chemicals, reference standards, and equipment is provided in a dedicated video segment. The test page guides the analyst through the testing phase. This includes sample preparation and interactions with the GeoPick instrument to obtain bulk density measurements. The first table on this page is designed to capture system suitability measurements. The second table is structured for samples and includes a row for each replicate measurement defined earlier on the samples page. Conditions at the time of analysis are documented. We begin the testing process by recording weights for each measurement in the gold cells provided. Limits may be defined for any type of data entry and excursions flagged or prevented. Weights may be recorded manually. However, for compliant labs, this might entail retaining and attaching a printed balance report. When recording a set of sample weights or other real-time measurements like pH, automation is both more efficient and compliant. SciCord's balance interface is initiated by selecting the balance resource recorded in this document earlier. Initiating the balance interface establishes a connection between the balance and SciCord ELN. The balance readings are displayed in real time on the instrument panel. Samples are placed on the balance and recorded to the defined cell once a stable reading is obtained. The ordering of weights is flexible. Samples may also be reweighed in case of a spill or other weighing entry. The audit history logs all measurement events and includes instrument details such as the identification of the balance, calibration date, and last daily checked. The benefits of instrument interface include eliminating archival of paper reports, preventing the use of an out-of-calibration instrument, comprehensive documentation of each measurement, and of course, avoiding transcription errors. The next step in this analytical process is to introduce standards and samples to the instrument and record the instrument reports. This template provides an interface for the GeoPick instrument, which listens for reports generated after each density measurement. For this demonstration, a GeoPick emulator simulates the process by generating a report every few seconds. In reality, the measurement takes much longer and requires the analyst to manually load each sample onto the instrument. The interface has captured report files for the blank, the suitability standard, and each sample. Interface files can be viewed. Each file captured by the interface represents the instrument report, including the instrument conditions, raw data, and final measurements. The instrument report file is associated with a standard or sample by selecting the cell provided and recording. The suitability standard report is selected and recorded to the appropriate cell. The instrument report attached is signified by a bold blue font and can be viewed. The attachment provides a comprehensive and permanent record of the measurement. Additionally, the contents of the report file are parsed into individual cells to display the final measurement and specific operating parameters which indicate the suitability of the measurement. As each instrument report becomes available, the report is recorded to the appropriate sample and sample replicate. Again, results and suitability information are displayed to aid reviewers and audits. Suitability and sample information can be reviewed and a disposition concerning the work recorded. We return to the samples page to view the final results. SciCord templates can automate any required downstream calculations. For density analysis, the measurements for replicate injections are averaged, and a pass-fail determination for each sample is recorded. Finalizing a write-up in a hardbound notebook often takes hours after the instrument measurements are complete. In SciCord ELN, the analytical documentation is complete once instrument data is recorded. There is no need to wrap up a notebook, saving significant analyst effort. A data tab can be selected to view sample results. The results obtained in this process are extracted into a structured data set, which is made available for reporting and visualization activities. The CBD results may be combined with additional sample testing to generate a C of A. The CBD results may also be consolidated with data from other samples for visualizations in packages such as Excel, Spotfire, or JUMP. To complete the documentation process, the document is closed. The document is signed electronically and is now complete. And that electronic signature is applied to all of the records created during the documentation process. This concludes our structured work demonstration describing ELN functionality, which supports more efficient and compliant laboratory documentation processes. Thank you for your interest.